Hello, now we are going to discuss about short circuit admittance parameters or Y parameters. Before proceeding, we need to understand what is admittance. Before that, let us understand what is an impedance of a circuit. Impedance. We have already discussed that impedance is Z, that is equal to, that is the ratio of voltage and current. Voltage to current ratio is known as impedance, and the admittance is actually admittance is the inverse of this impedance. Admittance Y, that is equal to I by V, that is the relationship between impedance and admittance. Otherwise, we can say that admittance is equal to 1 by impedance. Okay, right. Right. Now, let us try to understand each and every admittance parameters. For that purpose, we are going to draw the two-port structure that we have already discussed under topic two-port networks. Okay, right? Okay, right. This is the basic block schematic of a two-port network in which these are the input ports. One dash, that is the input port, and the corresponding current is I1, and the voltage across the input port, let us denote it as V1. Similarly, in the output section, we have port 2 dash. Okay, right. And the current drawn by the network, that is equal to I2, and the voltage across the output terminal, let it be V2. Okay, right. Short circuit impedance parameters can be defined by two equations. I1, that is the input current. Okay, I1 is equal to Y11 V1, Y11 V1 plus Y12 V2. Okay, simply admittance here, Y is equal to I by V. So what will be I will be equal to Y into V. Okay, right. Just take a look. Y is equal to I by V by this equation. Then we can say that I is equal to Y into V. Okay, that is what we are writing over here. Okay, I is equal to Y into V. Okay, next equation is expression for output current I2. I2 is equal to Y21 V1 plus Y22 V2. In order to find the short circuit admittance parameters, you should have to study these two equations. Okay, let us denote this equation as 1 and this one as equation number 2. Here y11, y12, y21 and y22 are known as short circuit admittance parameters. Okay, y11, y12, y21 and y22, they are known as the short circuit admittance parameters, and we should have to find the expression for these parameters, and we have to explain what is y11 and y12, y21 and finally y22. Okay, let's find the expression or equation for these four parameters one by one. Okay, we have already studied that the voltage across a short circuit will be 0. So simply short circuiting the port 2 dash, we can make V2 is equal to 0. Okay, right? So that is what we are going to do. So if we let V2 be 0 by short circuiting port 2 dash, Then, okay, if V2 is equal to 0 in equation 1, if V2 is equal to 0, this will be the situation. The output port 2 dash should be short circuited, then V2 will be 0. So if we substitute V2 is equal to 0 in our equation number 1, this is equation number 1. Now we are going to replace V2 with 0. Then the remaining terms will be I1 is equal to y11 v1 y11 v1 plus y12 into v2 is equal to 0 as we have short circuited here. So the entire second term will vanish and the remaining terms will be I1 is equal to y11 v1. From this we can find the expression for y11. y11 is equal to I1 divided by v1. Here I1 is the current in the input port 1 dash and V1 is the voltage in the same port, the input port itself. So Y11 is the ratio of current and voltage. Both this current and voltage belongs to the same input section. So we can call Y11 as short circuit input impedance. So now we could understand that why the name short circuit admittance parameters, short circuit admittance, because we can find the expression for these y parameters only by short circuiting input port or output port or input port. That's why the name short circuit admittance parameters. Okay, right. So now we go to the expression for y11, that is equal to I1 by v1. Let us mark it as equation number 3. So simply we can say that y11 is the driving point admittance at port 1 dash with the port 2 dash is short circuited. Okay, right. Okay, y1 is the driving point admittance at port 1 dash with port 2 dash is short circuited. Also y1 is also known as short circuit input admittance. Okay, now if v2, this is the present situation here. Okay, now if v2 is equal to 0 in equation number 2, what will happen? That is what we are going to discuss next. Okay, in equation 2, if v2 is equal to 0. Okay, if v2 is equal to 0 in equation 2, this is equation 2, then the remaining terms will be I2 is equal to y21 v1 plus y22 into v2 is equal to 0. Okay, right. Then the second term will vanish, then the remaining terms are I2 is equal to y21 v1. From this expression we can find the expression for y21, that is equal to I2 by v1. So we can say that this current I2 that belongs to the output port 2 dash, whereas the voltage V1 belongs to the input port V11. So this will be a transfer ratio as we have discussed under topic Z parameters. Okay, right. So we can say that Y21 is the transfer admittance at port 1 dash with port 2 dash is short circuited. Okay, y21 is the transfer admittance at port 1 dash itself with v2 equal to 0 with port 2 dash is short circuited. Okay, also y21 is also known as short circuit forward transfer impedance. Sorry, Y2 is also known as short circuit forward transfer admittance, not impedance. Okay, I have made a mistake. So now let us make the input session is equal to 0. Now we short circuited the port 2 dash. Next we are going to short circuit the input section. Okay, then we can find the expression for y12 and y22. Before that, let us mark this as equation number 4. Okay. Now, if V1 equal to 0, that means the port 1 dash is short circuited. Then what will happen? Let us draw the circuit at first. Okay. This is the basic two-port network. Now we have to make V1 equal to 0. Simply by short circuiting, we can make V1 equal to 0. Then V2 will be the voltage across the output port 2 dash, and I2 will be the current in the output section. Okay. So under this condition, what will happen to equation number 1 and equation number 2? Okay, now let us discuss one by one. In equation 1, what will happen if V1 is equal to 0? Here, this is the equation number 1. Then I1 equal to Y11 into V1. V1 is equal to 0 here. Okay, right. Here V1 is equal to 0. But we have written over here. Okay. So this term will be into 0. Then plus Y12 into V2. Okay. Now the first term and the first term will vanish. Okay. The remaining terms will be I1 is equal to Y12 into V2. From this expression, we can find the equation for Y12. That will be I1 by V2. Here also I1 belongs to port 1 dash, the input port, and whereas the voltage V2 that belongs to the output port 2 dash. So this Y12 will be, of course, a transfer admittance. So now let us define Y12 as it is the transfer admittance at port 2 dash. Okay, right. With port 1 dash is short circuited. Okay, right. Okay, Y12 is the transfer admittance at port 2 dash with port 1 dash is short circuited. Okay. And Y12 is also known as short circuit reverse transfer admittance. Okay, Y12 is known as short circuit reverse transfer admittance, and let us mark this as equation number 5. Okay, now let us discuss the same situation in equation 2 also. Okay, if V1 is equal to 0, that is the present situation. We have already short circuited. Okay, if V1 is equal to 0 in equation number 2, then what will happen? This is equation number 2, and then I2 is equal to Y21 into V1. What is V1? That is 0. Then followed by plus Y22 into V2. Okay, then the entire first term will vanish, and the remaining terms will be I2 is equal to Y2 to V2. Okay, so Y22 will be equal to I2 divided by V2. Then what about this voltage and the currents? I2 belongs to the output port 2 dash, and V2 also belongs to the same port 2 dash. Both I2 and V2 belongs to the same port 2 dash, that is the output port. And say that Y2 22 is the short circuit driving point admittance at port 22 dash with port 11 dash is short circuited. Okay, it is the short circuit admittance at port 22 dash with 11 dash is short circuited. And as I2 and V2 both these belongs to the output section, we can call Y22 as short circuit output admittance. Output admittance. Okay, right. Now we have to note one more thing. If the circuit is reciprocal or bilateral, then for a bilateral or reciprocal network, y21 will be equal to y12. Okay, a circuit. Otherwise, we can say that a network is said to be bilateral network, or if a network is said to be a reciprocal network, then the condition is y21 should be equal to y22. Then only we can say that the network is a bilateral network, or the same network is a reciprocal network. So for a reciprocal network, this condition should be satisfied, and the equivalent circuit for the short circuit admittance parameter can be drawn as this is the equivalent circuit, and we need to study this circuit by heart. Okay, this is y11 and this one is equal to y1 to v2, and this is y21 v1, and finally this is y22. Okay, in a question paper for the Kerala Technological University, or KTU, that was asked to draw the equivalent circuit for short circuit admittance parameter. So you have to by heart this circuit, and if it is asked to explain which are the parameters, then you should have to derive these parameters, or derive the expression for these parameters. So thank you for watching.